Hey, hi guys, hello. This is Elia, a specialist and LLM developer in Spartex AI Solutions. So, uh, today I'm going to explain the basic concepts, the how the big data is started their journey in the technology and how it is evolved from the on-premises to the cloud technologies. So while I'm working as a big data engineer on cloud, especially for the banking systems, so I worked for one of the biggest bank and financial services. So what type of jobs we were doing while working on the banking system and how we can getting the insights and reports from the data. So basically, I'm going to start this journey from on-premises legacy system to the cloud technologies like Azure and GCP and AWS. So let's get started. So today I'm going to explain now. So how the data is, initially how the every company, every big tech company like banking system, any banking system or health sector, anything it is, how it is saved their data in the normal legacy systems like RDBMS and how much data it is and how they are going to develop some insights, some ETL pipelines and some sort of techniques to generate the reports and the insights from that data and how we move the legacy system to the cloud technologies. Like these are all the concepts now I'm going to explain in this video. So in this video lecture series, so from day onwards I'm going to start a synthetic data, like a synthetic data which mimic the real banking system. So for understanding this you need to understand the software like software development life cycle, like what are the difference, what is the relationship between the entities like tables, on how how data is interlinked between the tables. You need to understand that. So then only you can generate the reports, useful reports, not reports, useful reports for the business development and insights for the uh, development of the business. So now I'm going to show what I developed to mimic the banking system and finance sector. So I already created some sort of 19 tables in my legacy system, which is my SQL server. So which mimic the exactly banking system. So from the nine tables, I interlink those entities by some sort of relationship like master detail or lookup, or like in terms of Salesforce, it is going to be master detail or lookup. In terms of normal, it's a foreign key, primary key, like that. So I'm going to, I already developed the relationship between those tables. There are exactly 31 tables, which will give some sort of real world banking system, how the banking system generate the reports and how they increase and how the banking system is making decisions based on their data. So here in this video, I'm going to uh, walk you through my synthetic database, which was I created by me. So let me show you. Okay, so I'm going to open my MySQL server, MySQL database. So this is my Linux distribution, Linux flavor, which is Ubuntu. So I'm not going to teach any basics things here in this series. So I'm going to, I'm in this entire video series, I'm going to develop the ETL pipelines from on-premises to the cloud. So, so what I do in this video series, so from I have a abundant data in the MySQL, which is on my premises. So I move this data, to the Hadoop cluster initially from MySQL to the Hadoop cluster by using Scoop, some Uzi schedulers or something like that, and by using some high queries. So I can make some sort of things. After that, I move on top of CD player. I'm going to build a data mart or data warehouse or anything which is useful for the AI, because right now I'm working in the AI field. So how we can use this data in the AI technologies, like, so this is my MySQL, which is working on port number 3307. So now I'm going to log in to MySQL server. So this is my SQL server. So I'm going to show my database, which is created by the me. So which exactly mimic the exact banking system. So which is show databases. So these are the all the databases which I have in my SQL server. So among this database, Kubera DBT, which is my database. So in which is for example, I have a bank like I have a bank uh, name called Kubera. So right now I'm maintaining. So just think like this. So I have a bank called Kubera. So I'm in not 2025. Think like I'm in 2000. So I want to store all the customer data and the transaction data in my database. So for that, right now I'm using my SQL because I don't have any cloud technology. So this Kubera DBT is my database, which can store the all the customer details and login and logout details in my legacy systems, which is MySQL. So use Kubera. Yeah. So show tables, show tables. Basically, the command show tables basically shows this all type of tables which I already have in my Kubera DBT. So there are totally 31 tables in my Kubera DBT which can track the all the information about the customers, which I mean in the banking system. So I build the relationship between all 31 tables by using some parent-child or child-to-parent relationships. So some of the tables are not necessary. That's why I didn't create any data in those. So the main tables is 31 tables. So these are the all the tables which I have in my Kubera DBT, which will really mimic the banking system. If you want to big data engineer, or if you want to big machine learning engineer, or if you want to AI specialist, you need to understand the how we can tackle the data and how we can generate the insights or reports from that data. Then only you can be a good engineer, or you can be a good AI specialist or something like that. So these are the all the type of these are the all the tables which I have in my Kubera DBT. So now I'm going to show the how these tables are interlinked. I mean, uh, to one to one. Okay, what is the relationship between every table? So okay, so basically, these are the root tables, means parent tables. So these are the independent tables. Independent tables. These tables are not dependent on any other tables in the entire 31 tables. So these are the parent tables or independent tables, which will operate lonely, which is not dependent by the any others. Okay. So these are the first level dependencies, childs. Like this is the first kids, first generation of the kids for these parent tables. Okay. So basically, security questions means while we are applying for the bank, some sort of security questions are giving at the time of login time, right? So what type of, who is your favorite hero? What is your mother's middle name, like that? It can generate. It will ask you some kind of security questions for the at the time of login. Okay, so this type of questions will stored in this data in this table and branches. So I have a branches all over the country. So in which locations I have my branch locations. So the type of information I'm going to store this branches table, and then customers. So you know that the customers can store in the customers table and the account types. What is this CASA? CASA means it's basically current savings and current savings and credit. I mean, uh, CASA means current savings account, current accounts and savings accounts. CASA means in banking system. So in this type, in this table, I'm going to store this the type of information like CASA information, like current account, savings accounts information, and then employees and who is the employees who is working in my bank, and then accounts. So these are the accounts which will depends on customers and branches and account types. So for creating any record in the accounts, I need a reference from the customers and branches and account types and the customer security questions. For building this table, re- if I want to build any records in the customer security questions, I want to take the references from these parent tables. Okay, so this is a third level dependencies. Okay, so transactions is the third level dependencies, which is directly depends on accounts. Account is indirectly depends on customers and branches and account types. And the transfers is the one more table which depends on accounts. So accounts is already dependent on some parent tables or independent tables. Okay, so transfers means the rate. I mean, how much? For example, I'm Alish. I'm going to transfer some money to my mom. Okay, so from which account to which account the money is transferred. So the type of information is going to be stored in the transfers table. And then loans. Loans is one of the main table which can which can track the information like if I give any loan or home loan or house loan or mortgage loan or auto loan. If I give any loan to the any customers, then the type of information is going to be stored on the loans table by taking the reference. Reference of the customers and accounts table because I need to give the loans to the customers, right, at the end of the day. So I need these tables help for creating records in the loans, okay, and the credit cards. So what for the credit cards is the one more table which can track the every information. What are the what are the credit cards issued for the customers or users, and based on the based on the so this type of information, all this stored in the credit card tables and the debit cards, like the same credit cards and the investments. Like investment means I'm going to start making investment in some other banks or some other things. The type of investments information are going to store in the investment tables and beneficiaries. Like this is not important really, so I'm going to. I'm not explaining this beneficiary table because this is not really. I didn't work anything on this beneficiary. If I have, a really very useful use cases from this table, I'm going to use this table also. Right now, just leave it simple. So customer documents, as you know, for the KYC, we need to, we need to store the customer documents for the verification. So the type of information are stored in the customer documents. So loan payments, if I issue the any loan payments, it's a child record to the loan. It's a child table to the loans parent loans table. So loan payments means how much I'm going to issue the money and how did what amount did I transfer to this particular customers. So loans is a one of the parent table for the loan payments. Loans is indirectly depends on customers. So this type of third level dependencies between the loan payments and loans and mortgages, auto loans. Mortgages means you can, if I issue any loans to the mortgages for the mortgage purposes, the type of information is going to store in the mortgages. And auto loans means if I issue any loans for the cars or any bike or anything, the type of information I'm going to store in the auto loans. For the credit card transactions, if I perform any, if I use any credit card, so I need to store that information, right? So the type of information is going to be stored in the card transactions, which is, card transactions is one of the child table to the credit cards, and credit cards is a second level dependencies, which is already dependent on first level, independent tables, and as well as debit card transactions and the investments. So if I make an investment, I need to make investment transactions between the people, entrepreneurs. So the type of information I'm going to store in the investment transactions. Okay. So audit log, audit log is a very useful kind of thing. Like which customer are, I mean, for example, I have a set of customers who are joining in the 2007. I have a set of customers who are joining in the 2008. So this type of join time, this type of special, I mean, special field or special column or special field, the type of information are going to store in the audit log. So service request, like if I want a new credit card or if I want a new debit card, I'm going to, request, I'm going to request a service from this bank. The type of information are going to store in the service request. So this is the one of the main table because so if you want to grab customers or if you want to hold the customers which is already I have, I need to make the service request very efficiently. So I'm going to generate more reports and insights from the service request tables and then complaints table. So complaints table is a, so for example, I'm a customer to the Kubera TV. I'm not satisfied with the service request or any other services which is provided by the bank. So I'm going to raise a one complaints to this to this bank. So the type of information is going to be complaints. So for the complaints, it completely depends on customer table and accounts table because so I need to know who is raising the certain complaint. For I mean those type of all the information are stored in the complaints. The fees, for the every transaction which is on credit card or debit card, that is going to be I mean I for running bank smoothly, I need to charge fees, right? So the type of fees, extra fees are going to be stored in the freezers table on the checks. So if I mean many people are working on checks, like issuing check to the pay their employer. So the type of information, checks information are stored in the checks table, direct deposits, like uh, if any customers directly deposits cash to the bank, I mean, for example, if any customers go to the bank directly and deposit their cash into the bank, the type of information are stored in the direct deposits, which is indirectly depends on accounts. Accounts is already indirectly depends on customers table, independent tables, and the password history, login attempts for the security purposes, and the APS keys and behavioral score. This is the one of the important thing. So behavioral score is the very important thing. So for every banking system, if I want, so for example, if like if if Rayudu is a, for example, my friend name is Rayudu, is a very good customer to the bank. So he's apply for the loan. So I need to issue the, so I need to issue the loan for this guy. So how can I know if this guy is good guy or not? If this good guy making transactions, on time, or he's going to, he will pay the, credit card bills and credit and all the things, and he's making some good balance in the accounts. So based on all those circumstances, so I'm going to build this behavioral score table. So these are the all the tables. So independent tables and first level dependencies and second level dependencies and third level dependencies and the special purpose tables. These are the all the tables which I build in my SQL servers. So for initial task, I'm going to migrate this all the data to the Hadoop cluster. So on HDFS, after that, I'm going to on top of Hadoop cluster or HDFS, I'm going to migrate the data into the cloud for the, I mean, so because every company now moving to the cloud, so I'm going to move this legacy data to the cloud. So this is the plan I have. So I will show you how many records I have in every table. These are the records. Don't worry about these. SQL statements. I already developed for accessing, for showing how many records in each tables having. Yeah. These are the tables which I have in my KuberDB. Every table has this abundant of data. So the transactions is one of the main table which will hold, which is already holding 14, nearly 14 lakhs, nearly 15 lakhs records, and password history is the same, and card transactions and loan payments and checks and transfers and interest, the card payments and notifications. All the tables are holding some type of abundant data. So this is the synthetic data. So which will mimic exactly the real banking system, how the banking system generate the reports, how they are going to build ETL pipelines for the certain things. So in this course, I'm going to explain all each and everything from the starting point. Okay, so that's why I created this database. So if you want to learn more about data engineering things, you can stay with me and you can connect with me. So thank you. Have a great day, guys. Bye bye.